Alrighty, guys. So let us get into the situation. Like I say, I'm going to do one or two examples, just recapping what we know, because as I said, number patterns are like a foundational concept when we're talking about relationships and graphs. So it is important to understand what's going on. I'm really hoping that this goes a little bit better than the last class. I don't know if I was just losing my mind a bit, but we'll see what happens. Okay.
It will definitely go better. I believe in this, and you, my peps, I believe in you. We'll get this.
I definitely had a moment where I felt like I was doing something weird.
No way, everything was fine.
Okay, before we do that, I hope I'm pronouncing your name correctly. If I'm not, you can correct me. Mukhadi, do you have a question before we get started?
Yes, ma'am.
Yes.
Yes, ma'am. I was asking if we're gonna be learning about numeric and geometric patterns.
Okay, so like I say, we're not actually doing number patterns now. This section is actually graphs. The pattern videos are on the website though. So they are, and I stand to be corrected, I'm pretty sure there are numeric and geometric pattern videos on the website if you want to recap that.
Okay, thank you, ma'am.
There's that. Okay, guys, so let us have a look. We have got a pattern created out of matchsticks below, and have a quick look of it. If you need to take a screenshot before you get started, go for it. Essentially what I want you to just start off with is consider what is the image, how does it change from one term to the next. If you want to, you can count the matchsticks in each term to figure out if there is a pattern going on, and then I'll give you like a minute or two, and then if you want, you can raise your hand and tell me some of the things you're noticing. Is there a pattern? How does one image change from the next, and so on. Lisa's already got her hand up. She's on it. Okay, if you're struggling a little bit to start, my advice, count how many sticks are in each pattern, and then use the numbers to see if you can find some sort of relationship or some sort of pattern going on. Okay, Palesa, Modise, what do you think is going on? Palesa, are you there?
Yes, ma'am.
Okay, what do you
so,
think?
ma'am, is there going to be 9?
9 what?
Ma'am, the sticks?
Yeah?
Yeah, 9 sticks, ma'am.
Are being added each time?
Yeah, ma'am.
Okay, so how many sticks make up the first picture?
12.
12. Okay, and what about the second one?
So 12 plus 12.
Why 12 plus 12?
That is 24.
But why 12 plus 12? Let's count the sticks together. Everyone, oh golly, Miss Molly, so sorry. Let's count. 1, 2, 3, 4, 5, 6, 7, 8.
Ma'am, the reason why I'm saying 12 is because the first one was 12, and then now we have another one. So don't we add the same number?
Okay, so guys, this is an important sort of thing to see. Do you agree that if I took that picture and I sort of put it on there, like, oh, I don't know how to do this without creating absolute chaos. Let me try. So there is sort of the first bit of my image, but do you agree that this triangle on the end is now sitting over there? So this sort of middle bit is what I'm adding. I'm not overlapping. So I'm adding an extra 1, 2, 3, 4, 5, 6, and there should be 7. I don't know where I'm missing one. Oh, 7 sticks. So as Naledi said on the group, there's actually 19 matchsticks making up the second one if I go and count them. So again, if we just double check the counting, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's not a complete like 1 star, 1 star, 2 star, 2 stars. Like there's just like a middle section that we're adding. Do you agree?
Yes, ma'am.
Okay, cool. So how many sticks then are in the third image?
26.
Excellent. 26. Okay, so what's happening each time? What's my pattern?
We are adding by 7.
Good, well done. Okay, so guys, and like for some people, looking at the pictures is a little bit easier than writing the numbers. For some people, writing the numbers out is a little bit easier. But as Pelesa's just said, if we carry on this pattern, I can see that to get from the first term to the second term to the third term, I'm adding 7. And so in this question, where it's asking us how many sticks will there be in the fourth term, do we agree I just need to add another 7?
33. Yes.
Right. So the fourth term or the fourth image will have 33 matchsticks in it. Yeah?
Yes, ma'am.
Did you have a question? No.
No, ma'am.
Okay, cool. So guys, just by looking at our pattern, just by looking at what we're adding or subtracting each time, in this case, I'm adding 7 each time, I can get to my next one. So quickly, how many matchsticks would I have in my fifth image or my fifth term? You can put your hand up, you can put it in the chat. How many would I have in the fifth term? Mukhari, how many would I have? Tell me.
Ma'am, you would have 40.
Excellent. Well done. What about the sixth one, Mukhari?
Ma'am, we would have 47.
Okay, excellent. So each time we're just adding 7.
Yes, ma'am.
Good. Well done. So guys, what we can see here is that our pattern is that I'm adding 7 every single time. And this is sort of where we need to go when we start to understand what graphs tell us. So here I'm asking you, what is the rule for this pattern? Now, if you haven't done number patterns, this might be a little bit more challenging. And so again, go and watch the videos on Watobe's website after this lesson. But when I'm talking about a rule, either I want a rule that says y equals and then some sort of equation. Some of you might do it with tn equals and then some sort of formula. At this point, I don't have a preference, which we're eventually going to start to talk more specifically about this. But for now, Ntokozisi, what do you think the rule is?
Ma'am, we add 7, ma'am.
Okay, perfect. So if I wanted to try and write it as an equation, let's think of, oh golly, let me draw a quick table. Let's think of x as being our term number. So term number 1, term number 2, term number 3, and y being how many matchsticks. So 12, 19, 26. So I want a rule that's going to get me from x to y. Right. So guys, as Ntokozisi said, that addition of 7 is a super important part of finding this rule. So let's see. Kwakukle, what do you think?
I think it will be 7x plus 5.
Excellent. Okay. So here, our rule would be 7x plus 5. Now, if we're not understanding where that's come from, let's do a quick check of why that is. Like I said, and as Ntokozisi said, that plus 7 is so important because we can see that that's the thing that's getting me from one term to the next. Now, whenever I can see the same thing being added each time, that actually becomes the coefficient to my x. So if I start with that idea and I say, okay, well, what's 7 times x for the first term? So 7 times 1. That only gives me 7. I know that the answer I want has to be 12. So then I say to myself, okay, if I'm studying with 7, what do I need to add to 7 to get 12? Well, I need to add 5. That will give me my y value of 12. Then I'm going to go and double check that this works for my other one. So if I now say 7 times an x value of 2 plus 5, does that work? Well, 7 times 2 is 14, and 14 plus 5 gives me 19. If I keep going, so if I now check it with 3, 7 times 3 is 21, plus 5 will give me 26. And so each time my rule is working for the specific pattern that I'm looking at. Now, again, guys, if this is unfamiliar to you, I really encourage you to go and watch the number patterns videos. We are going to chat more and more about these rules, but essentially knowing what we're adding or subtracting each time is going to help us get to our general rule for the pattern. Right, I'm going to speak more about this in a second, but let me just answer these questions. Tato, do you have a question for us?
No, ma'am, I wanted to give the pattern, but it's okay.
Okay, so did you give it in terms of X and Y? So
Yes,
did you?
I wanted to say the same thing that
Okay.
the other person said, but I
So you
forgot to
agree
lower
with
my
it?
hand.
No
Yes,
problem.
ma'am.
Good,
Okay.
well done. Well done, Tato.
Thank you, ma'am.
All right, Amike, so you can correct me. Do you have a question for us?
Yes, ma'am. I wanted to ask if, like, how did you actually get the 5? Because, like, I saw in previous times there was like a +2, and like, yeah, it's kind of confusing.
Okay, I don't know if maybe you can speak a little bit closer to the microphone or put the microphone closer to you. You were a bit fuzzy there. Let me see if I can hear you again. Otherwise, type it in the chat for me and then I'll try answer.
So, like, ma'am, what I wanted to say is that, how did you get the 5?
Okay, cool, perfect. So I got the 5 because I started off by saying the 7, or me adding 7 each time, that's clearly important for my pattern. If I asked you to describe in words what is happening, you would say I'm adding 7 each time. Now that 7 actually becomes the coefficient to my x. So I know with that 7, I'm starting off with 7 times x. But I know that if I go now to this beautiful table I've drawn, if I say 7 times x, so 7 times this 1 here, I only get 7. My answer needs to be this 12. So what do I add or subtract to 7 to get 12? Well, I add 5. And that addition of 5 then gives me the rule that will work for each of my terms. Does that make a bit more sense?
Yes, it now makes sense. Thank you.
Good, well done. Right, so guys, I suppose the clue is when we're adding the same value each time, what we want is to understand that that becomes the coefficient. Like I said, don't stress. We're going to talk more about this, and there are videos for you to go and watch, but just understand that that addition of the same number each time is so important for our relationship. All right, so I'm just going to jump a little bit. Let us jump to what I actually want to chat about today. And that is talking about different types of variables or different types of values that we're going to use to start drawing graphs and to start describing relationships. Okay, now what is important is that we understand that different variables and different values can affect each other differently. So you can take screenshots of this, but really I want to be able to just get some hands and see what you think as we go through these. I want to see from you, or I want to ask you, how do we think these values are affecting each other? So if we look at the first example, I've got the number of calls that you make and the amount of airtime you have. So how do you think, for example, the number of calls you make affects the amount of airtime that you have? Do you think it's going to increase your airtime? Do you think it's going to decrease your airtime? Is it not going to do anything? What do you think is going to happen in terms of the number of calls you make and the amount of airtime you have? Okay, Manentle, what do you think?
The airtime will be finished, ma'am.
Okay, so the more calls you make, the more airtime you're going to use, right?
Yes, ma'am.
Perfect. Okay, so guys, do we agree that, and let's try and write this as neatly as possible, the more number of calls I make, So the higher the calls, the lower your airtime. We could also go the other way and say the more airtime I have, the more calls I can make. But at the end of the day, what we need to understand is that every time I make a call, I'm taking up airtime. So this would be like a decreasing relationship, as Tulani has put on the chat there. And so if we just start to think about this visually, if it's going to decrease, if I make more calls, so as the number of calls increase, and my airtime is then sort of the two variables or the two partners I'm looking at, as I increase the number of calls, my airtime is going to decrease. So I'm going to see this decreasing or sloping graph to show that with more calls, I have less airtime. Right, now again, we're going to get to drawing these graphs beautifully, but it's important to understand how variables and how values affect each other. All right, so I still see some hands. If your hand is up because you have a question, leave it up. If you were going to answer, please lower it. We're going to do another example and there'll be a chance to answer. But I just want to make sure I deal with any questions before I move on. All right, Owami, do you have a question for us?
Ma'am, I just wanted to ask, so why would the graph decrease downwards or instead of another direction?
Okay, so, good question. Let's just like very basically talk about this. Let's say for every call, so one call costs R1. Let's just say costs one rand. Now, let's say, for example, there's my beautiful graph. Let's say I start with 10 Rand airtime. Okay. Now, that's what I'm starting with before I make any calls. So no calls being made, I've got 10 Rand airtime. Are you in agreement?
Yes.
Okay. If I now make one call, do you agree that's going to decrease my airtime to 9 Rand?
I agree, ma'am.
Okay. If I make
it could also decrease even less if you
say that again.
The call extends. It could decrease even less if the call is even longer.
Absolutely, absolutely. I'm really like simplifying this relationship, but I agree. The longer your call, the more it's going to cost. But I'm just saying, let's just pretend a call of any length is 1 Rand. We agree that as I make more and more calls, my airtime is going to decrease by 1 Rand each time. Okay, and this is why my graph is going to decrease like that, because every time I make a call, I'm using up airtime.
Oh, now I understand, ma'am. Thank you.
Okay, good, well done. Okay, so guys, as Owami said, like obviously in the real world, calls cost like per minute or per whatever. And so the cost would definitely be different for different calls. But if we just simplified, every time I make a call, I'm spending money, it's going to decrease. Alrighty. So let's have a look at the next one. So the number of matches in each picture and the number of triangles created. So basically, how does the number of matches you have affect how many triangles you can create? So think about if I had, I don't know, 2 matches, how would that affect? No, that's a poor example. If I had 6 matches, how many triangles would I be able to create or make up versus if I had 100 matches? Okay, Naledi, what do you think?
Ma'am, if we had 6 matchsticks, then we'd have two triangles.
Okay, cool. Now, if I had, let's say, 2, 4, 6, if I had 7 matchsticks, how many triangles would I be able to make?
Ma'am, I think, I'm not sure, ma'am. I think maybe 14. Oh, 3.
Okay, so if we have a look here, just generally, the first picture, I've got 3 matchsticks. The second one, I've got 5. The third one, I've got 7. And as I keep going, obviously, I'm going to have more matchsticks. So that would be 3, 4, 5, 6, 7, 8, 9, 11, 13. Okay, so what we see, hopefully, is that the more matchsticks I have, the more triangles I can create or I can draw. So, Mukhadi, do you agree with that? Or do you want to add to it?
I don't understand because how can you make 3 triangles out of 7 matchsticks out of 100?
Okay, so I was just using that as an example. It wasn't a great example. I was trying to get it, or trying to let us see that if we have more matchsticks, I can make more triangles. So if I'm only sitting with 3 matchsticks, I can only make 1 triangle. But if I've got 100 matchsticks, I can make so many more triangles. Do you agree?
Yes, ma'am.
Okay, and so that's what I'm trying to get to. The more matchsticks I have, the more triangles I can make.
Yes, ma'am.
Okay, more triangles. Excuse my shorthand. Clearly, I'm very lazy when I write things down. But that's what we need to get. And so if we think about this in terms of a graph, as I increase my number of matchsticks, I also don't like that I put it there, but it doesn't matter. I'm increasing my number of triangles. And so my graph will now start to increase. And this is where we're heading with graphs. Okay, good. Well done.
Yes, ma'am.
Right, guys, does anyone have any questions about this before we have a little break? But essentially what you need to start understanding now is that variables or values can affect each other. And that effect that they have on each other is what we're going to eventually start drawing in terms of our graphs. Right, Pumazile, what's your question?
Ma'am, I'm not sure my network is good, but can you hear me?
Yes.
I wanted to ask.
Yeah.
When figuring out the next term, how exactly do we do that?
So like for the triangle one.
Yes.
Okay, so for example, I can see. Can you maybe mute yourself just because I can hear? Oh no, there we go. That's better. Right. Okay. I can already see some people in the chat saying this, but what I can see is that as I move from my first image to my second image to my third image, etc., I can see that each time I'm adding an extra 2 matchsticks. So when I then want to figure out how many matchsticks I'm going to have in the next term, I just keep adding 2. And I just keep adding 2, and that will get me to my next term as I go along. Right, so Pumazile, does that make a little bit more sense now? Okay. If not, pop it in the chat or send me a message and I will hopefully help you a bit more. Khonse, what is your question?
Ma'am, it's not actually really a question. Ma'am, can you please move up? I just want to take a screenshot of the first exercise we did.
Oh, sure. This one over here.
Yes, ma'am.
Okay. So guys, take a screenshot of this first one if you would like. I'll quickly move back down to the other one and then we'll take a quick break before we carry on. Okay, here's the other one. Alrighty, so, and we'll come back to this obviously. This is our brain break for the day.
Brain break my lips.
Right, I will be right back. I'm running to the loo. Yolanda is here to help you.
Yeah. Guys, so first let's just recognize this joke, okay? It's, what did the calculator say to the students? You can always count on me. So I really appreciate this joke. I found it a little bit lame, but it's really fun. It's funny also. So I'm guessing that those hands there is for us to figure it out. Guys, can we do it a little bit different today, ne? So what I want everyone to do, I see those hands, ne? What I want is the final answer. So I don't want the steps in between. So we're gonna just sort of congratulate the first person that gets the final answer. What is the final answer? So all those hands that are up, I know that you put your hands to give me what is a snail, what is whatever that is. I'm really bad in animal names. So if you wanted to give me those, please lower your hand down, because all I want is a definite answer. So we're not taking any answer in between. We're doing it a little bit differently. I just want to get what is the answer, the final answer, where the question mark is. We're looking for that answer. So if you have any answers in between, Umzile and Amiti, if you have any answers in between, today we are not interested in that. We're doing it a little bit different and fun way. So make sure that you do sit down with your calculator, with your books, figure it out, give us the final answer. That's what we're looking for. And Teacher Sam, I guess you will help me whenever you realize the final answer on the chat that is the right number. We're going to shout out to the students, and it's the student that wins for our brain break.
Oh, laka.
Yeah, so we're doing it a new way. So whoever writes the first answers on the chat, or whoever raises their hand to give us the first answer, that's what we take. And the person will explain to us, how did you arrive to the answer? And that will be the end of our brain break. Yeah,
I like this.
Yeah, because always we give them clues. So I think it's about time for everyone to figure out their numbers.
I think so. I think I also need to start finding some harder ones.
Yeah, but also these ones are interested. Actually, because I think that they've been helping each other, then they arrive there faster, and no one actually does any calculations, because of course all the numbers gets given to you. So this time we're doing it a little bit different, my pips. We're only looking for the correct number. So Teacher Sam, I haven't done it, so I don't really know what is the correct answer. So if I see,
I'm not seeing any correct ones yet, but I will send you a message as well with the correct answer.
Okay, thank you. Thank you. Like this, I can check the numbers, because I didn't do the calculation. I'm busy talking to you about people instead of doing my own calculations. So let's go. Let's see the votes. Let's go. Okay, now I already have an answer. Let's go. So
I am
none
doubting
so far
myself,
on
so
the
let
chat.
me just double check.
Oh, no. Okay, we have to double check.
I believe in myself, but
okay, are we
today
good
has
now?
made me doubt myself. Yeah, I think so.
Okay.
No, I'm backing myself. I can do maths.
Okay, so definitely we have a winner for today's quiz, my people. Linneo, you are our winner. Linneo, if you're not shy, can you please raise your hand so that you can explain to us how did you get to your answer, and the class will listen to you. So if you're not shy, Linneo, please raise your hand, because you are our winner today in today's quiz. Well done. So Linneo, I see that Kukanya also got it. So Linneo or Kukanya, can you please raise your hand so you can explain to us how did you arrive there? If not, I guess I'll just give it to someone else if you're shy to explain, and then they can explain to us. Yes, congratulations to them. That's good. There we go, Linneo. Thank you. Linneo, explain to us, how did you arrive to the answer of 202 as your number? So you need to unmute on your side, and then you can just explain quickly. Yes.
Ma'am, can you hear me?
Yes, we can.
Cool. Ma'am, so like for the final answer of 36, ma'am, I divided it by 3, so I got 12 for snails.
Good.
So then I moved on to bugs, and I times the bugs by 20 plus 12, which gave me 412.
Good.
So then I used 20 plus 20 times 16, which gave me 340. So then the final sum, there was only one bug, so I divided 20. So it was 20 divided by 2. So I got 10 plus 16 times 12, which gave me 202.
Excellent.
Well done, we nailed it.
Linneo, before you go, I want to ask one question. When we've got, like in these last 3, where there's a multiplication and an addition, do we do the multiplication first, or do we do the addition first?
Ma'am, the multiplication first, because you could get a different answer if you start with adding.
Excellent. Well done.
No, you nailed it. I don't think that we need any explanation by Pips. So today's winner for the Brian the Break is Linero. We're giving it out to Linero. See you guys next time. Well, it's not the end of the class, just on the brain break. Just to ensure that. Yay! There we go. Teacher Sam rated it there. Well done. Well
It
done.
is now on the record.
Yeah. Well done, guys.
Well
It
done.
was a
I
nice
like this
brain
way
break.
of doing brain breaks. Nice, guys. Okay, so I'm hoping we all gave it a try at least. Let us continue on with our functions and our graphs. Okay, so what we're sort of heading into now is talking about different variables and then talking eventually about how we can express these relationships. And one of them is going to be graphs. We need to understand all of the formats to get to graphs, and this is sort of where we're heading up to. But you're going to see as you do more and more maths, and especially if you plan on doing maths in like grade 10, grade 11, grade 12, there are so many different types of graphs that we end up drawing. And so understanding this whole relationship between variables is really important. I love graphs. It's one of my favorite sections in maths, just because there are so many cool relationships and so many cool graphs and so many cool things we can do with them. So this really is a very cool section. Okay, so at a very basic level, when we talk about the values or variables that we're going to work with, we talk about input and output values. Okay, now, some of you, when we got that rule for the pattern earlier, we're using X's and Y's, and this is sort of a good lead in into input and output. So your input values are represented with an X. And basically what this is are values that we perform operations on to get an output. And I'm going to try to put that all down. Values we to get an output. There we go. Okay. So when I say perform operations on, I can say to you, times your X by 2 and tell me what the answer is, or add 1 to your X value and tell me what your answer is. Or I could say times your X value by 3 and subtract 5 and tell me what your answer is. But basically we perform a whole bunch of different operations on an X value in order to get an output. That output sort of now links to this next bit, which is our Y. So this is sort of the answer after doing all of the operations. So answer, I know my handwriting isn't great, guys, I apologize. Answer from okay. And these are the two important variables or the important values that I'm going to work with as we start to talk about graphs and as we start to talk about equations of graphs. There's an input and there's an output. Now, if you remember from when we did transformation geometry, so when we looked at like reflections and rotations and stuff, if you guys weren't there for that, don't stress. Hopefully we've all at least heard of something called the Cartesian plane and coordinates. If you think back to that, I'm sorry, I'm going to sneeze. Oh, excuse me. If we think back to that, thank you, Tato. If we think back to that, coordinates are an X and a Y value. And so graphs plotted are coordinates, and we can then join the points to form a relationship and to form a graph. Okay, so this is where we're going. If you haven't got this, thank you guys. I appreciate all the bless yous. I think there's something in the air at the moment. So take a screenshot of this if you haven't written all of it down, and then we're going to have a look at how we now apply this concept of input and output. Alrighty. Okay, so sort of easy examples to start off with. We're going to have a look at just like when we buy things, what is the relationship between how much I buy and how much I spend? So there's a very basic example. Let's say apples cost 16, everyone's sneezing in this household. Let's say I buy apples and apples cost 16 Rand a kilogram. So my first question is, if I buy 1 kilogram, how much do I pay? How much am I going to pay for 1 kilogram of apples if it costs 16 Rand per kilogram? You can put it in the chat. You can raise your hand if you want, but that's my very first question. Okay, I see Rio Betswe is here. Theo, nice. Mahadi, what do you think? How much am I paying?
Oh, ma'am, right. Your question was how much would you pay per kilogram? So ma'am,
sorry, yeah.
It's okay, ma'am. What are you about to say?
No, keep going.
Okay, ma'am. I was gonna say 16 because it states in the statement that 16 Rand per kilogram.
Excellent, well done. So guys, if I just buy 1 kilo, it's gonna cost me 16 Rand. Right, how much is it gonna cost me for 2 kilograms? Check it on the chat, put your hand up, what do we think? Palesa Modise, tell me what you think.
Ma'am, it's gonna cost 32 Rand.
And how did you get 32?
Ma'am, I said 16 plus 16.
Good. So we're buying 2 kilograms now. Each of them cost 16 Rand. So either we can say 16 plus 16, or we can say 16 times 2. Either way, you'll get exactly the same answer. Okay. Mukhadi, just because I can see your hand still up, how much would I pay for 3? Oh, no, you left me.
No, ma'am, I didn't leave.
Okay. Mukhadi, tell me how much I would pay for 3 kilograms.
I mean, you'd pay 48 Rand.
Excellent. Well done. So 48 Rand. Right. A bit of a curveball here. How much would I pay for half a kilogram? So how much would I pay for 500 grams of apples? Tando, do you want to try?
Ma'am, would you pay 8 Rand?
And how did you get 8 Rand?
Ma'am, I divided by 16 by 2, ma'am.
Excellent. If I'm only buying half a kilogram, I'm only going to pay half the price of 1 kilogram. So it would be 8 Rand. Well done, everyone on the chat. That's awesome. And Nathaniel, well done. We are dividing it by 2 in order to get our answer. Now that we've had this discussion, what we can do is we can start to put this in terms of an input and an output. So the inputs, if we want to think of it like a little bit more scientifically or a little bit more specifically, your input would be your independent variable. So the thing that doesn't really make it, like, it has no effect on the other variable. No, that's the wrong way to describe it. Your independent variable is sort of what we would usually put on our x-axis. And in this case, we're talking about how many apples are we buying. I can buy however many apples I want. The cost then depends on how many apples I buy. And so my cost or the price is then the dependent variable. I'm going to use X's and Y's because this is what we need to get used to. So if I think about my input as being the number of apples I buy, and my output then being the price or the cost of those apples, I can then start to form a table. Okay. So we spoke about the fact that 1 kilogram, and let's maybe change this number of apples to kilograms of apples. That's a better description. 1 kilogram would cost me 16 Rand. You guys told me 2 kilograms would cost me 32 Rand. 3 kilograms, 48 Rand. We sort of went on a bit of a tangent here, and I said, what happens if you buy half a kilogram? And you told me it would cost 8 Rand. But essentially, there's this relationship that for every kilogram I buy, I'm going to pay 16 Rand. So let's try quite a big number. What happens if I bought 12 kilograms of apples? How much is that going to cost me? Excuse me. Okay. Whoops. Lolita, how much is it going to cost me to buy 12 kilograms?
Hello, ma'am.
Hi.
It would cost 192 Rands.
Excellent. Cost me 192. Now, what did you do to get that answer?
I multiplied 12 by 16.
Excellent. Well done. So yes, the pattern is I add 16 each time, but now if I give you a very big number, we don't want to keep adding 16. And so we see the shortcut is to say, okay, it's 16 Rand for every kilogram I buy. So times it by my 12 kilos, and it gives me my 192. Okay, so we're leading up into getting a general rule or a formula here. Zalama, do you have a question for us? Oh, no, okay. Right, so could someone tell me someone give me like a general equation or a general rule for how I could find, sorry, my cat's walking on the table, how I could find the cost of apples regardless of how many kilograms I buy? So like, what is a general formula or a general rule to determine the cost of apples if it's 16 Rand per kilogram? So Piwe, what do you think?
Y is equals to 12 times 16, I guess.
Okay, so 12, do you agree, was the number of kilograms?
Ma'am?
So 12 is how many kilograms we bought, yeah?
192.
Okay, good. So guys, the 12 is the number of kilograms. If I take that back to my X and my Y, that represents X. So this would be 16 times X, because for every kilogram I buy, it costs me 16 Rand. And so if you want, you can write it as Y is equal to 16X, or you can write it as Y is equal to 16 Rand X, doesn't really matter. But what we've been able to do is we've been able to get like a rule that we can apply to get any cost. So now if I say to you, I don't know, you were throwing like a party and you bought 100 kilograms of apples for whatever reason, you can now just say, cool, what's 16 times 100? Let's say, I don't know, you bought 500 kilograms of apples, 16 times 500. And so with a rule, you can determine the cost of any amount of apples that you buy. Yes, Piwi, does that make a little bit more sense?
Yes, ma'am, got it.
Good, well done. Alrighty, guys, so let's have a look at a final sort of situation where we're now going to start to get these rules and start to get these relationships. So take a screenshot if you haven't done so already. We're not going to do the whole thing, so I would take a screenshot of this next image. I just want to chat briefly about it. Another way we can start to express these relationships is through a flow diagram or a spider diagram, however you choose to think about it, it's completely up to you. But this is the same sort of concept. Now, I sort of think of these like a machine. So I'm going to put something into the machine. So there's my input. So these are all my X values. The machine is going to do a whole bunch of stuff to my input. And I'm going to then get an answer, which is my output value. And so that would be my Y coordinate. So if we follow the first leg or the first branch of this diagram, we have got an input value of -1. It's going to be chucked into my machine. My machine is going to times it by 3 and then add 2. And I want to figure out what my output is. So you can put your hand up, you can put it in the chat. What is my output when I do all of those operations that I've been told to do? Tulane, what do you think? Oh, sorry, I think I clicked on the wrong person. Oh, or did you leave me? Okay, that's all right. Claire, what is the output?
The output will be -7.
Okay, can you explain how you got -7? I agree with you.
I said -3 times 3.
Which is?
-9.
Good.
Plus 2, it means -7.
Excellent, well done. So guys, we perform the operations and we get our output. Well done. Right, let's go to another one. Let's just do the next one. Ooh. Wild scenes here. I've got an input of 1. I'm going to do the same operations times 3 plus 2, and I need to figure out what that output is. Okay, some weird lines going on here, but it's fine. Tulane, do you want to try this one?
Yes, ma'am.
Okay.
Is equal to 5.
Excellent. So 1 times 3 is 3, plus 2 is exactly that, 5. Well done. Right, so guys, you can finish this off if you want, but I suppose my next question to you is, could you give me a general rule? Could you write an equation down that expresses what this whole number machine spider diagram thing is doing? So if I wanted an equation for the X into the machine and then the output, what would my equation look like? Emmanuel, tell me.
Evening, ma'am.
Hello.
Ma'am, so it would be 3x plus 2.
Okay, and that would be equal to y.
Yes, ma'am.
Good. So y would be equal to 3x plus 2. And so this, guys, is going to start the basis of being able to draw a graph. It is expressing the relationship or the operations happening to my input in order to get an output. Right, really nicely done tonight, guys. You worked really well. We got through some awesome stuff. Yolanda, are you still there?
I am.
Oh, okay. Cool. I was a bit worried.